all the different aspects. We're not turning this into a programming tutorial by any stretch, but I will say a few words about the three primary options you have for programming languages, and I threw in some pros and cons about them. So it's the general stuff. I hope we can get through all this tonight. There's a lot there actually. If there's any questions, interrupt. Stick your hands up, yell, throw something at us, doesn't matter. Okay. So, like I said, we're going to cover a whole bunch of stuff. Control system overviews, communicating with your robots at home competition, driver station, FRC updates suite, imaging your RoboRio, basics around networking, a little bit around programming, and how do you deploy your code from your laptop onto the RoboRio so it runs. A few gotchas to watch out for. A whole bunch of online resources, which also reminds me I probably should pass this thing out. Oh! Hopefully you didn't get that on video.
I did.
Job now. I got it.
Talk a little bit about programming options. There are some duplicates in this deck because there's three of us actually presenting. We'll introduce them in a second. So there's a little bit of duplicates. We're going to probably skip by a couple of slides because of that. Animation. So what this isn't, and I'm going to hand it over. For some reason I lost some slides here. We're going to hand this over to Nick in a second. I'll explain who he is. This is not a full guide to programming your robot. This is not advanced configuration of your robot. This is really just setting it up. Okay, I'm going to go back. People are going to be presenting is really me facilitating this thing more than anything else. If you don't know who I am, my name is Max Callback. I'm the president of FRS, which means nothing other than I do a bunch of work. I am also the lead control system advisor at the event. Been involved in since our first regional here. My son joined, went to Bishop Grandin, and I sort of got sucked in. He went into grade 12, found girls and dropped it. And I kept it, so I'm still here. So I'm one of the guys at the competition that runs around with the orange hats, trying to make sure that you can get your robot up, running, and keep it up and running for the entire competition. So we look after and help you, not do it for you, help you with the control systems, the whole aspect of just getting it up and running. Programming, we try to have people who have an understanding of the three primary programming languages so we can help here. And Nick McCluskey, McCurry, wrong. I know McCluskey. So Nick is an alumni of Bishop Grandin. He just started going to SAIT here this year. He is the person that I used a lot when at the competition last year and other years to help me make sure everybody's up and running. This year, since he is an alumni of 1482, he is going to see if he has some time, without interrupting his schooling, to help do some of the CSA work on the competition itself. And everybody knows Craig Maynard. He is our Director of Innovation and Training, and he has graciously volunteered to assist in the CSA role as well this year. And we'll probably have one or two other ones, hopefully. We have a lot of rookie teams this year, probably in the neighborhood of probably
10,
which is a lot for a competition actually. Nick, all yours.
As Max introduced me, I'm Nick. Just quick show of hands, who's here
Who here is this your first time on an FRC team? Are you guys done? About half. Okay. So basically, I just want to talk to you guys about the control system and what you're going to use to actually make your robot work. So with the control station, the main three parts I'm going to talk about today are the driver station, so that's your laptop where all the programs are run. The RoboRio, that's basically the brain of the robot. And then the wireless access point. That's what actually sends all your data from the RoboRio to your laptop.
There's actually a driver station up on that laptop that we just switched to. If you want to show it.
Sorry?
Oh, yeah, just, you gotta go to that.
Right.
Yeah. No, it's,
Or maybe that rebooted too.
no, get a power button.
This is the driver station that you'll actually use to drive your robot. So I'll go over how to install all this and how to make it work.
That's as big as it gets on the screen then? Like on your,
Driver station?
yeah,
You can get it a little bit bigger, but that's pretty much it.
okay.
So a lot of you guys, if you've been on team last year, you'll recognize this router, the same one that's over there. This year, First Robotics decided to change things up a bit. They went with this router here, which I lost my notes. It is an open mesh router. The special thing about this is it comes with no firmware. It's got no software on it. If you want to put your own on it, you have to put your own on it. First is rumored to make their own installation tool for it, but it's not released yet. It's going to come with a kickoff package. So rather than dealing with this D-Link, it's going to be this new open mesh. So it's a lot smaller. It has a lot better power requirements. And First is able to customize every single feature on there rather than having to mess around with like the D-Link configuration menu. So I won't go into too much depth on how to configure it because it's going to be a lot different next year. So then just start off with the driver station. It's used to drive your robot. It's the most basic part of it. It basically just takes the input from your controller, your keys, whatever, and forwards it onto the robot, as well as like e-stop, disable, all that kind of essential stuff. Every year there's a new version. So whenever kickoff starts, you're going to push out a new version, and then throughout the year they're going to update it. So when you're at competition, you got to make sure that you have the most up-to-date version. About a week before the competition starts, they'll say that you need to have this version of the driver station. If you don't have that version, then you won't be able to go on the practice field. They're going to force you to update before you can even connect to the field. So make sure you have that before competition. It saves you a little bit of headache. And then this is download the FRC update suite. So when you download that every year, it just comes with it. And it just looks like that. I don't have a robot connected to it because this is just a screenshot off my laptop. But that's the basic setup of it. So the FRC update suite, that's what you'll actually download every year to get started. It's released every year at kickoff. So generally a few days before, they'll put it up on the web, encrypted with a password. Then at the very end of the kickoff broadcast, they'll say the password so you can all go and unzip it. So especially if you're able to, download it in advance. Because the second the kickoff happens, everyone's website basically starts to crash in my experience. So if you can get it beforehand, it's really helpful. And then this is what contains the essential tools that you'll need. So it's got everything from the RoboRio imaging tool, used to image your RoboRio over there, to the FRC gamepad if you want to build your own custom driver station with cool buttons, and everything in between. So for updating the RoboRio firmware, you've got to use one of those old little printer cables, USB-A male, USB female, or no, A male to B male. Most of you guys see these on printers, but that's what you have to start connecting to your RoboRio. If you just connect with the Ethernet, it won't work right away. You need to set everything up. The RoboRio has a web interface, so if I can pull it up on here. doesn't work, there's one other way to access it.
There you go.
Oh, that's our,
That's the dealing.
So when you set it up, you always set punch in your key name. If you want to access it through this, what should work, it's a bit more advanced than DNS responders, but RoboRio dash your key name or key number dot local, and that will bring you to this screen. So this is how you control it. Rather than the last versions, you have to run software on there, basically click go, and it just uploads everything. This year you have full control over everything on the software. So when you need to update the firmware, if you just log in, and unless you changed it, it should be admin and blank. And then you can go to RoboRio and just click update firmware on the bottom. So that'll be the newest files. Every year there's generally a new firmware update. It will come with that update suite. So you just got to select it and then click upload.
If you're a rookie team, do you get that access too, to download the RoboRio software?
Yeah, you can download last year's right now. It should be in one of the links on there I sent you to. It's basically just a zip file. It's got the little password written on there. So you can download this and install it ahead of time. Just keep in mind that you're probably going to have to do all this over again, but practice doesn't hurt. So when you're looking for the file, if you guys have the PowerPoint, you can just look off there. But it just tends to be installed with the National Instruments files. So you can just select it off there. The name's a bit confusing. It says CRIO. Trust me, it's for the RoboRio. I don't know how to do that. So the other program you can use to actually image it once you have the firmware updated is if you go to this program, you'll get a cool imaging tool called the FRC RoboRio imaging tool. This is where you actually have to upload the firmware for this year, or upload the image for this year. So the firmware is more interacting with the hardware. This is more upper level. It actually runs the code. So when you go in here, you'll set it up. It'll detect the RoboRio. You have to have it plugged in through that USB cable. Punch in your team name, select the image, and click go. It's really simple this last year, a lot simpler than CRIOs if you guys have been around for a while. But it's basically click and go. Okay. And then I'm going to talk about just how the network works a bit. So a lot of you guys, if you're new to robotics, I know I was at first, I didn't know how at all this could possibly work. How could your computer remotely control this massive robot? It's very simple. It's just Wi-Fi. The same thing that your phone uses to download the internet, watch your movies, uses the same principle. The one thing is it doesn't have internet though. It's got something called intranet, and unless you're a networking major like me, you don't really have to worry about that. Just know you can connect to the router. You won't be able to connect to the web. You'll connect to any device that's connected to it. So when you're at home, this router is going to be set to like a router at home. You'll connect to it with your phone, your computer, and everything, and it will work just like you do at home. It'll give you your IP address and everything, and it'll be the same thing with the open mesh. At competition, that's when it gets a little bit more tricky. So because we don't want people hacking the robots and someone in the stands connecting to your robot and then just shutting it down, whatever, in the middle of competition, your robots actually connect to FMS. So if you guys are interested, that little stick right there in the middle, that's the antenna for the field. So it's directional, no one else can really connect to it, and your robots will just automatically connect in your schedule. So just make sure when you are out testing that your robot doesn't actually accidentally start up. If your computer is connected to the robot, it should be fine, because it's the one that actually sends the enable command, but just be wary of that. And then the other thing is your computer is just wired in, so it goes into that cabinet back there. That's the FMS cabinet. So every you guys see connected to FMS, it just means you're connected to the field management system. It controls when your robot's on and off. You don't have to worry about that. You just have to know that your router is not connected to your computer anymore. If you try and connect, it won't work. And then at home, just direct connection. Okay, another slide. Is this your slide, Matt?
That was the one that Max, he just left.
Max?
He wandered off. I'll go get him.
I'd like to get a complete picture. So when you were talking about getting the FRC update suite,
Yeah.
are you going to an FRC site on the internet to download it?
It's actually National Instruments website. They're the ones that host the file. They make the driver station, the update tools, the RoboRio itself. So they've got the link hosted on their website. I've got the
Okay,
link.
so you take the RoboRio,
Yeah.
you hook it up to your computer with the USB cable,
Yeah.
and then you have to log into that site, or whatever
Yeah.
site, and then you punch in your team name, and then it downloads it to your RoboRio? Is that how it
You'll
works?
already have it downloaded. You're just selecting what file to use, and then that will put it on the RoboRio for you. So you don't need internet to actually upload it. You just need to download that file once in the first place and install it all.
You're just downloading one file.
Yeah. I can actually show you guys on my laptop if you guys want. So, just in case you guys are curious, this is a VM. It's basically a computer inside a computer. So this is brand new what you guys will see if you don't have anything installed. This works. Okay. So when you download the software at the start of the year, I already just downloaded it for simplicity's sake. The link is in that file. You'll get,
The link is in, I'm sorry, which files?
it should be aired in the documents, isn't it, Max, at the end?
All the links are there.
Yeah. You'll get a file like this, or the downloader from National Instruments. Once you open it up, this will actually contain all the files you need. It's just a one-click installer. So if I can extract this.
But I have to go to the National Instrument site to get that.
Yeah,
Okay.
if you just
You already have it on your PC.
Yeah, I just downloaded it just because I didn't know how the internet would be here and didn't want to play guessing games. But actually, this is downloading.
So now,
I assume this is your slide, Max, or do you want to talk about it? Or?
Yep, this is mine. Nick has already mentioned some of these, and there's a lot more gotchas than just these 3 points, but I just threw these 3 points in today. Nick mentioned of upgrades of firmware and driver station at times. Last year, there was a very large number of upgrades that was released after build. You'll need to update things. The problem is if you're updating some of the firmware of the RoboRios and some of the Talons, some of the controllers on your robot, you can't touch it because it's bagged. So at the start of the competition, Monday, April 4th is unbagging day. The first thing you'll probably need to do is update all your firmware and software on the actual robot itself. You can update all the driver station, everything that's on your PC at any time, because that's not bagged. But everything else that's on your robot, you're going to have to spend some time first thing Monday morning updating it. Part of the issue that we always run into is the fact that at the Oval there is not internet connection for you to download things off the internet. The CSAs will have a whole bunch of jump drives that we will be putting, a whole bunch, 4 or 5 anyway, that we'll be putting all of the updates on it. So you're going to need to come to us, borrow one to make sure everything gets upgraded so that you will be able to go practice and your robot will actually run on the field. So that's fairly important. Most of, in this case, Monday morning for the CSAs are running between teams, making sure everybody has the proper upgrades so that they can actually operate. A lot of people, what they do for the no internet connection is they run their phone as a hotspot and they connect their laptop through the hotspot into the internet, which is fine if you're far enough away from the field. There are no internet, or Wi-Fi spaces, hotspots that you should have when you're anywhere around the field. Because what you don't want to do is interrupt the field systems. Is that right, Craig?
That's right.
Okay, that was it. I don't know what's next, maybe some more.
I've got this.
Okay.
So when you actually unpack everything and download it, you'll get something that looks like this. All you have to do is just run the setup, and that will pretty much download and install everything for you. Well, it'll download and install the programs. You just have to run those programs, and it will update everything for you. So just when you get your NI software update for FRC 2015, just click through, choose the things you want. If you just don't want to install the game tab, let's say, because you don't need it, just check off, exit out, and just basically agree to privacy policies. Click next, over and over you go, and that will actually download all the files. So like I referenced on one of these slides here, so once it's actually done, just go on your computer, go to this one you have to go to the website. This file will be created for you. You just choose upload, and then it will start processing through that. So that one you have to be on the website for the D-Link. And then to actually image it, you run this program here, and it will pop up everything for you. I'm going to see if I can switch quickly to that version to show you guys.
So at this point, your RoboRio should be plugged into your laptop.
Yeah. Throughout the whole time, once you download the initial program, you don't need internet again. So you can basically connect directly to your RoboRio to get everything else set up. Serial number, if you don't have it, you don't need it. But at kickoff day, on the back of your national instruments package, you'll have a CD with LabVIEW installed on it. You can use that on your computers if you want to program LabVIEW. If not, just flip the back over. It's got a little serial number. That's what you can use to activate all these programs. None of them really need it. It's just a little bit better and you get a few less prompts if you activate it.
So if you're a rookie team and you install that, you just go to the next?
Yeah, just click next.
Okay.
It'll say activate again. Just exit out of that and you'll be fine. Everything still runs perfectly fine now.
Okay.
But we can't upload that until the day of kickoff, right?
You can actually.
You can upload it before, but you'll have to do it again at kickoff.
At kickoff. So is there an advantage to doing it before kickoff? If you
Oh,
have-
yeah, you can practice that.
Oh, okay.
Yeah. You can learn a lot about it. There's a lot of resources available.
Okay. So then when you go back after kickoff to upload it, does it tell
Well,
you?
chances are at kickoff, you're going to have your little laptop that's given to you, right? The small one. You can load this program on any laptop you want, right, from National Instruments. Isn't that right, Nick?
Yeah.
But then during the kickoff, you'll have a little laptop with just all the setup files to load LabVIEW onto, right? And then you'll just do it over again. It'll be a fresh install. And then updates and stuff like that.
Oh, okay, so it just kind of replaces what's on the
Yeah.
RoboRio or whatever the new stuff is.
Because every year they're adding new features to it. You don't want to get left in the dust running 5-year-old software. So there's new safety features they always implement. I don't know what the game is this year. They've released a hint, but there may be something that the driver station needs to do differently in accordance with that game. There may be a new motor controller that's legal. So all that stuff is just contained in the update so that everything will happen. And then, just give us a second before it finishes that. Basically, I jump through the installation process. This is what it finishes. If you just click next a few times, you get to the same point. It just takes about 10 minutes to install, so this is just a little bit quicker. But if you go to that file location I was talking about, the computer, C drive, program files 86. And then you can kind of see all the FRC tools start to just show up in here. So, national instruments. And this is something you normally just want to look off the sheet. I don't need to actually look at that. Yeah. So there's the file. No, I don't want to run it. So when you actually connect to the robot, you just have to basically tell it what firmware file to use, and you'll upload this. Then, so I can't remember the other one. Now these are the other tools that you'll have to use. So historically, this bridge configuration utility tool, this is what you'll run to actually configure the router. I'll just pop up to show you guys now. Oh, okay. I'll show you that in 1 second. But with the, let's see here. With the RoboRio imaging tool, after you've got the firmware updated, just open up the imaging tool. And this is where it's going to search for all your RoboRios. So I'm just going to quickly hijack the robot for a sec and show you guys what it'll look like when you actually detect it. So when you scan for the RoboRios, there should just be one that pops up on the left. It's going to cooperate with you. Cruelty of life errors. Still important.
Programming languages. There's really 4 options for programming languages. LabVIEW is National Instruments base language. So it comes with National Instruments RoboRio. It is what they use to program this. LabVIEW is also a language that is used for National Instruments production control systems that is used in oil refineries, processing plants, all that stuff around the world. So it's the same language. So it has a lot of capabilities from that side. It's a block diagram interface, as you'll see a little bit when some of Craig's slides, I think, shows it. No real detailed programming experience is needed, so you don't need to be a hotshot programmer in other languages to use it. It's really easy to use for rookie teams or teams that have limited experience in the other languages. That's where I would recommend it. If you are a rookie team, or if you're in a situation where you don't have a lot of experience on an existing team with Java or C#, C++, or Sharp.
C++.
Okay. Then I would suggest you use this. An example is Nick's first year at Bishop Grandin, which was Grandin's probably 8th or 9th year competing in FRC. They went back and used LabVIEW. They used it because they didn't have the expertise with Java or C++ to use those languages. So they went back and used LabVIEW for a year. Nick was there. He wanted to do it in Java, so the next 2 years since then, they've been using Java. Just because they had the experience there. The cons around it is you can lack some finite control that some teams might want to take advantage of. You don't need to. So this is pinpoint controls, pinpoint doing different things. It's less transferable skill set with it. If you know Java, you know Java. It's used just about anywhere from your cell phone to everything else. If you didn't know, the guy who invented Java graduated from the University of Calgary.
James
Born
Gosling.
in Calgary. James Gosling.
Yeah. My next door neighbor.
I have a picture of him. Right? Ever showed you my picture?
Oh.
I'll show you my picture. He's my doppelganger.
Yeah, he looks a bit like you.
Yeah, a lot like me, actually. C++ and Java, I put them both in the same thing. They're industry common languages. They're used everywhere. I run an IT team for an oil and gas company downtown. We use a lot of Java and a lot of C++, so it's essentially everywhere. Usable outside. What we use for Java for FIRST Robotics is really a very simplified version of Java. A lot of your controls are on the libraries that you download from FIRST. Again, I'll use an example from Grandin. Last year, they were contemplating using Mecanum wheels. If you don't know what they are and you want to know, I can explain it to you later. Versus just our regular arcade drive, tank drive, round wheels, just normal stuff. And for Nick to make the switch from one set of wheels to the other set was just one library. He had to change one line in the code. Because all those libraries are there, they are just dead simple to use, and it does a whole bunch for you. Those languages will give you the ability to do absolute finite control of your robot and do a lot of different things if you want to go there. Like I said before, you don't have to. You can succeed really well without having to do that. Somewhat depends on the game though too.
If you don't mind me adding on, with Java and C++, you get something called version control. So basically, you can see all the changes you make throughout. You can say that Nicholas McCurry on this day at this time changed this line of code. He left this message saying added support for shooter. So for example, if one day your code stops working, you can go back and see what you've changed. From all I've seen in LabVIEW, you don't really have that control. You kind of just got to know what you've changed, go one step at a time, and you can't really go back to old versions. Am I right with that, Craig?
No, you can. Yeah, there's version control.
There is version control?
Yeah.
Oh,
Yeah,
I
it's
should have known
different.
that 2 years ago.
It's yeah.
Okay. Yeah, never mind that then.
And any, well,
Version control is built into it, right?
yeah.
It is.
Yeah, in this case, it's first, I don't know if it's their directive or recommendation that they use source control on GitHub, right?
Yeah, they're sponsored by GitHub, so they have a lot of sites for that.
GitHub is a source control code-based language, not language, but source control, source code repository. It is also open to other teams to go pick out and use. That's one of the good things about FIRST is that they want you to actually help other teams. So if somebody develops a piece of code in Java to do one particular thing, maybe from last year, it's probably out there for you to go take a look at, pull down the code, and use or modify.
It has to be up there. That's actually part of the rules. If you write code from last year and you want to use it again, there's a certain date that you have to have that code uploaded by. So if you just go on GitHub and search a different key in their key number, you'll be able to most likely find their code from that year. Just so you guys know. If you're ever stuck on something and you just need to look at an example, it's a really good way just to see what other code and APIs teams have written. Few tasks.
Okay, and the last point here is the cons, really. If you're going to use C++ or Java, I would strongly suggest that you have a mentor that understands it to be able to help you. That's really, really useful. If you don't know it, but you want to use it, learn it before January 9th. Because you don't want to be learning a programming language after the competition starts. Python is the other one. There is, when I say there's the four, C++, Java, LabVIEW, and Python. Python is the libraries for FIRST Robotics has been written for Python, so they are there for you to download. Python is a fairly common language out there. It's quite easy to use and to learn. It is used in some industries, commercially, but it's not anywhere close to being as popular as Java or C++. I think the library was written by Joel, actually. So, Joel Golan was one of the top people on 4334 for many years. He was speaking out of this. Now he's a mentor there, actually. I think he's the one who wrote those libraries, and gave it the first to publish. The cons around it is, again, you need to make sure you have the proper mentors. We have one team at our regional last year that used Python. They had a bit of a problem with it. We couldn't find anybody to know it to be able to help them. So think twice about it, even though it's possible. If you are really good at it and you're hotshot with it and you're really comfortable with it, go for it. But if you know a bit about it, use something else. My suggestion.
We have a female Python programmer though, and
Pardon me?
we have a female Python programmer, so she knows, she likes to help everybody too, so.
Perfect. So if you want to use it, there's a source for you. Last year we had the issue of, like I said, the CSAs not even knowing it. We know it, but not enough to help anybody.
She's also gonna volunteer at the first event, so she'll know.
Perfect. That was great stuff.
Okay.
Hey Max, can you tell us what a CSA stands for?
Pardon me?
What does a CSA stand for?
CSA is Control System Advisor.
Oh,
Those are those own chat people that run around trying to help everybody get their robot up and running.
Well, we've been able
Again, we're talking about the RoboRio control system. We're going to look at some of the modern FRC control systems, so the individual elements, wires, wiring principles. You've all seen the kit of parts. This is last. Oh, this is. Wait a second. Oh yeah. Okay. Yeah, we're on the right track. So last time, as you alluded to, we were talking about all the components, the hardware components, and how things are all brought together to make a control system. Now we have to start talking about the guts of these things and how you actually bring them up to standards, get them to operate together, get all the software to work as one. So there's a very, very useful reference library for you on a website called LabVIEW Program. It gives you all the information you need, and I can kind of make reference to it as we go through this presentation. So, first thing we got to do, we already talked about this, we have to configure the radio for your home use. Without the radio, you're not going to have this system work at all. The radio is the communications, it's the telephone that allows your control system to talk to the field management system. That's the FMS system they were talking about in the competition field, or to your local computer, like I'm doing right here. I got mine set up wired, but you can also set it up wirelessly. So I can communicate between these, my laptop, my operating system there, and this system through the radio. So the radio has to be configured correctly, all right? And there's a couple of steps they talked about how to configure the radio. Now, as you alluded to, they're going to change the radio this year. There's going to be a whole new setup, but the principles are going to be the same. The radio itself is basically going to have its operating system inside here reconfigured to communicate with your software for your particular team. The team number that you're going to be associated with is actually going to be burned right into this radio, so it becomes useful for your team and only for your team. Now there's a real good summary on how to set up the team number and how to configure the radio. It's right in here, WPI library summary. So you can click on that link if you can we put this thing up on the website too?
Yep.
Yeah.
Yeah, and it'll take you straight to how to configure the radio, and of course, you'll have the new version when the new radio comes out. Okay? Next thing you want to do is you want to install LabVIEW. Okay? This is the LabVIEW installation process we already talked about here, and WP actually has a fantastic description on how to get LabVIEW installed. As you know, LabVIEW is the native programming language that National Instrument uses for most of its programmable logic controllers and control systems. It's also the language you use for creating the dashboard and all the interfacing. Okay. This is the WP link right here that describes in great detail how to install any old versions of LabVIEW you've got, how to bring up the LabVIEW installer, and it takes you step by step through the entire process. So everything you need to do to install LabVIEW, it's all right there. Now, once you've done that, LabVIEW itself is the common programming language. There are a bunch of specific libraries for FIRST Robotics. There's tools that are brought on board to make you interface to all the hardware that the FIRST Robotics offers you, and you have to bring all that stuff in too. So it's one thing to get the base package. You also want to bring in all the options and accessorize it. So LabVIEW is assumed to be appropriate for many platforms, not just FIRST Robotics robots. So updates must include as well any modules unique to the FRC robot. Okay. So again, there's a link right here that would take you to the page that would give you all the FRC tools. And how to install those tools. Now, do you guys know what firmware is? We've been using terms like firmware and images and things like that. You guys familiar with those terms? Firmware? That's probably a good thing to know. Inside every one of these computers, whether it's a RoboRio or a telephone or a smartphone or a laptop, there's a little microprocessor. And the microprocessor itself isn't specific to any single system. The microprocessor is just a small machine, but it needs to have instructions to make it behave in the way it needs to behave to be what it is. The microprocessor in here, for instance, might be the same microprocessor I got in my smartphone. The difference is the firmware. This is the operating system for the microprocessor that gives it its identity, right? So the firmware in here makes this thing a RoboRio. Makes this thing understand that understand that it's got inputs and outputs. It's going to be talking to a robot. It's going to have communications with this particular system. It defines the microprocessor and makes it a RoboRio. Okay, so firmware is a very, very low-level operating system, and it has to surround the microprocessor to give it life, to make it understand who it is. Okay, just like when you're born, your firmware in your brain makes you a person, makes your brain understand you've got arms and legs and nose and eyes, and this is my basic system, and these are the hardware I have attached to me, I can run them. But you really haven't got much of you don't know how to talk, you don't know how to walk, you don't know how to do anything else. You have to start loading in higher levels of instructions on top of that. Okay? So your firmware made you a person, right? But as you grow, you have to have a larger program, and this is the image that we're talking about. So, the firmware, it's always changing, right? It's improving with time. They're finding bugs. See, whenever FIRST has a problem with security, whenever FIRST has a problem with people hacking in, or maybe packets being dropped, or problems with the system, they fix it by changing sometimes the image, the big software, but sometimes they have to go right into the firmware and change it fundamentally. And that's what we're doing here. So the firmware is an important update, and you have to keep it updated all the time, right? So the firmware goes through revisions over time, and like Max said, so you're going to have an updated image and an updated firmware probably when the competition starts. And you're going to have to upload that new firmware. So firmware goes through revisions over time. This is done using a web browser. You can actually log into your RoboRio using an ordinary web browser, and as he described, upload firmware. And this is the link that will take you right to a page similar to this that will describe how you update the firmware. Does that make sense? Okay. Firmware? Okay. All right. Now, the firmware is only the first step. The next step is training. It's the imaging of the actual software inside there. There is RAM and ROM inside here that actually has a program running, right? And the program is involved in keeping this thing communicating with the PC and operating with the dashboard the way it's supposed to and doing all those basic controls. So the image is a larger, more sophisticated program that runs over top of the firmware and the hardware itself. It's a framework for your first robotics event. Right? It allows the robot to operate in competition and to interface with the FRC dashboard, so that's the image. All right, this image must be downloaded with RoboRio, and it is not included in the basic hardware configuration. The image is written in LabVIEW, right? Compiled, and then programmed into that particular system. So, in addition to the firmware, you got to update your image. This is the imaging tool that we talked about when you get your National Instruments disc and all the FRC options and things for it. You'll have an actual link to this page, or to this folder where you've got the imaging tool, and you just follow the instructions as he alluded to get that image burned onto the thing. Okay, you can click on this little link right here, and it'll actually take you to the page on how to image. Curve slide. That can work for me. Okay, and here's all about how you image the RoboRio. It's all set up there. And like you said, there's two ways of doing it. One of them is through the Cat5 with the network cable. Much more convenient to actually plug into the USB port right onto your system and then blast it in there. Yep.
How much space do you have for the image?
I think it's like 4 megabytes, something like that. I'm not sure how much memory is inside the thing, but a few megs for sure.
It's not much.
Not much. Not much. I'm not sure. That's a good question. Yes, how large the image was, how much file space is on board for the image? I don't know. But once it's in there, it stays in there. You turn that system off and turn it back on again, the image is ready to go. So that link will help you image. You okay there? So firmware talked about. It's a LabVIEW-based interface. It allows drivers to communicate, troubleshoot, control their robots, right? Gives you this big old panel. I've got all kinds of data here. My team number would be right there. It shows me the voltage of the system. It shows me I'm communicating. And the robot, there's actually code that I've written and downloaded into here, because that's the third level of programming. The third level is you have to take your code that you write that's going to make your robot specifically do what you want it to do, and you have to take the code, compile it, and then put it over top of the image and of the firmware on here. So obviously the code's running and there's no joysticks connected, and it gives you all the information you need here. And it lets you operate in what's called teleoperated mode. It lets you operate in practice mode. It lets you connect to the field management system. All shows up right there. Also has a bunch of logs here. Keeps you in touch with all the stuff that's going on. So if there's any problems with your software or hardware or communications, the messages will show up there. All right? We'll look at some of the driver station links. There's one of the links right there. There's a zoomed in version of it that talks about how it's communicating and how things are going. But I'm not going to go into any detail right now. It's too much information maybe you guys want. That should be the link right there. And favorite links. Yeah.
Is this a part of the firmware we were just given?
Yeah, there might be parts of it in there, yeah. Yeah. All right. So, there's different kinds of programming languages out in the world, as you know, and every one of them has their strengths and weaknesses. But when you talk about C++ and Java and Python and those kinds of things, that's a structured language. It's called a structured language, and it's a textual language. A structured textual language. That means all your instructions take the form of pseudo-English commands, right? Pseudo-English instructions that are then compiled and then sent to the processor inside there. It's something called machine language. So structured text is Java, C++, all those guys. You've got to really understand it. Now, it is a demanding language, and there's wrong ways of learning it and the right ways. You really have to understand the principles of Boolean structures. You've got to know what integers are, floating point numbers are, binary numbers, hexadecimal. It's a lot of foundational stuff. you should know to get up to the next level. But I know in a lot of high schools they teach you Java and they teach you C++. And if that's the case, it's a great language to use. But it's not a good language to dive into the middle of. It's not a good language to be a script kiddie and sort of grab other people's codes and try to jam it in there and see what it works, because you'll burn yourself out real fast, right? Very hard to use. Great language, obviously very powerful, but you should climb the ladder, really make the best use of it. Another kind of a language that are used in some systems is called function block diagrams. Function block diagrams are languages that are more graphical in nature, where images and shapes perform all the functions that you need to do. Okay? And function block diagrams are an example of an function block diagram, FBD, is a LabVIEW. LabVIEW is a function where all the elements, all the individual components in your programming language take the shape of little icons. And the icons are all connected together. Now, have you guys ever played with Lego Mindstorms at all? Have you played with it? Anybody else have played with it? You played with it? You played with it? You were playing with function block diagrams. You're playing with logical elements that had certain inputs. They did things, right? And then they produced certain outputs, right? And sometimes they could pass data to another block, into another block. Sometimes they controlled motors. Sometimes they, for inputs, they had the sensors and touchpads and sounds and things like that. For outputs, it could have motors or screen displays. And you just locked the functions together and they flowed, didn't they? So one function kind of moved into the next function, which moved into the next function. Sometimes events or things would happen to make it go from function to function. Sometimes they just moved over time. Sometimes they moved instantaneously, right? But they flowed. You see, a program is like it's like a bunch of gears in a clock. I'll show you something here. I don't know if this is going to work. This is kind of like a program right here. And the program consists of a whole bunch of little tools, little functions that are operating. Each one sometimes working independently, sometimes they're tied into other functions, right? But they're all working together to make the program one, like a machine, right? So your programming language is like a machine instruction. In fact, the core language that every microprocessor understands is called machine language, right? It's unique to that language. So every one of these guys is like a little process. Maybe this process here might be involved in bringing in data from the joystick. Maybe this process here might be involved in doing math operations, adding or subtracting. This process here might be involved in saving some data or writing some data, right? And in structured languages like C and those kind of, these things are called procedures, right? And these procedures are called, they do something and sometimes they'll return data back to the main program again, right? They all have to work together. In function block diagrams like LabVIEW, every gear is called a virtual instrument, a VI. So we'll look at that in a second. Okay, so this is LabVIEW Program. A lot of really cool resources are out there on the National Instruments and on Chief Delphi and on WPI on how LabVIEW programming works. And again, if you're not really comfortable with structural languages and you're not quite ready to dive into a crash course in C programming, just for this, it's a little bit more friendly, right? There's all kinds of procedures that are pre-written and all set to communicate and work with your system all the way. That's just how LabVIEW works. So let's have a look at, just click on here, you can have a look at this particular link. These are called screen steps from WPI, step-by-step processes of how to create a program. Now a program in a FIRST robotics robot isn't just one program, it's usually many programs working together. Some programs are maybe looking for targets. Other programs are managing the communications from the joystick to the motors. Other programs may be doing other things in your robot. So all of these programs are all kind of running together to get a job done, right? You put them all together, it's called a project. So the project is a collection of a whole bunch of little programs. And And in this talks about how you create a project and how you configure them. Basically, when you set it up, you know, give it a name, give it a team number so it knows what to communicate, because your team number is burned right into your radio, so it knows to communicate with that team number in that radio. The way you want to run it. And it creates all these little, what are called virtual instruments, which are little gears. Each of these things like a little gear in your program. And then this is a little section on how to run the program, how to deploy the program. That means to take the program from there and push it into there, so it's running inside your system there, right? And all that stuff. And then suggestions where you go from there. So another cool, very cool site for you guys to learn about LabVIEW programming. Okay. There's this is a bunch of video links right here that'll actually take it through if you're one of those kind of learners who like to read but want to see videos on how to do this stuff. It's called the FRC Mastery site. And this is a little older, but they've got an updated version as well. This is videos on how to set up the projects, for instance, right here. You click on that, hopefully it'll work. Right? Beautiful little explanation that'll sit down and talk to you all about that.
First robotics competition, instructional videos. This year, it was put together something called the 7 steps to FRC. The first step is to start a new code to work for your robot. We're going to go through the
We
default
won't
code.
go through this thing right now because it'll just probably bounce off you. You'll get lost anyways. But you just go to the FRC West page, and these both of our websites, or both of our presentations should be up there for you. That's a great resource. Okay. So what is LabVIEW? How does LabVIEW actually work? Again, it's a graphical-based function block diagram program. It develops sophisticated measurement, test, and control systems. Really good for flow. Really good for process control. Right? As Max alluded to, in the oil and gas industry, when you have vats of compounds that have to move through other vats and chemical processes and temperatures are added and taken away and sequential things are going on, you like to have a flow, and it's nice when your program also kind of flows, right? You can see it a little bit better. So it interfaces with a variety of hardware. It scales across different targets and operating systems, so it will work not just on Unix-based systems, but it'll work on Windows systems, it'll work on all different kinds of systems. And it's got all kinds of built-in analysis libraries and things like that to keep track of how the thing's actually running. It's sort of how it looks. You see, it's like a picture. It's like a schematic diagram. Okay? Information in graphics always flow from the left side to the right side, so you always read it like a book. Right? Stuff starts here, trickles through it, comes out there. The first most important part about LabVIEW, guys, when you play with it, is this thing called Project Explorer. That lets you look at the project and all the programs that are running herein, and you can organize your project files. You can detect and resolve errors and broken links and stuff from here. You can deploy it, which means send it into there. Deploy it and download files to your target, in this case the RoboRio. You can manage the code for build options. You can integrate with source codes. Now, you can actually, these individual blocks in LabVIEW can be created with LabVIEW, like that little block, I don't know, like that block right there, can actually be a C procedure. It can be written in C with input data and output data. And if you open that up, you'll just see a bunch of C code, right? So you can actually open these things up and see it gets too scary, and you just back one level away and just look at the picture, right? So these individual blocks could be written in C, could be written in Java, could be written in Python, anything that's supported. And then they get plunked down there as a picture. Okay, so that it integrates with other kinds of codes. Okay, there's 3 kinds of files that you have to worry about in LabVIEW. Only 3 kinds to worry about. One of them is called the actual project itself, which is the big picture. It's all your stuff, your robot language will be a project, right? And it's called the LV.PRJ extension. You can have a virtual instrument, which is called a VI, and that's the individual blocks themselves. And then you can have custom control, which could be a C application or Java or something like that, custom control applications. So you can see elements there's my project right here, the weather station project. It includes all of these things. And it includes controls like the weather station states control, weather data control, and it has these VIs, which are like the meters in the clock. Weather station VI, temperature warnings VI, and then dependencies, which we won't worry about at this point. Okay, so your VIs, every VI, which is the working part of your program. I'm not getting into too much detail here. I'll skim through this. Okay, every VI only has 3 parts to it. One of them is called the front panel, and the front panel's got all the controls and stuff in there. You can turn things on and off, change data, look at information, that kind of stuff. It's like a control panel, right? Behind the control panel is the code. So you can see this code right here. It's a relatively simple little VI. It takes this double word, which is it's called a 16-bit word, right? A 32-bit, sorry, it's a 32-bit word called A, and it's adding it. You see now, A is added to B. So we're adding it, and the result's going to something called A plus B. So A is right there, shows up in the input. It's adding in there, and A plus B shows up there. A minus B shows up down there. So A is subtracted from B, shows up here, and it shows up there. So this is like a control panel. Sometimes we even have to go into this level. This is far enough, right? You can see what's going on in the individual elements. It's your block diagram of the VI, and that's the connector plane, which kind of shows how all the VIs are tied together. So those are only 3 parts you have to worry about. There's another front panel. You can build a front panel to do anything you want. You can build front panels for your robots that'll have windows open, sees what the camera sees, lets you process some of the fancy targeting information. You can actually see the X and Y values of a target and maybe use that to aim your shooter for your robot. And it can just show up right here, right? And behind that is the block diagram. That's the front panel. There's the block diagram. And then you can see all the functions right there. So there's the number of measurements, how it shows up on your control panel. There it is in the block diagram. And this is what it's doing. And here's an output called temperature chart. There it is, right there, right? This is the wait until next delay multiplier, which is a knob. And there it is, right there. Okay? So the cool thing about this is you can get the Red Hot programmers to write this. And the drivers and stuff just see that. Very cool. Very nice interface to use. Okay. Or connector panes again describe how all these little blocks are all tied together. The icons themselves represent the VIs, which can have all kinds of stuff going inside them, all kinds of little math functions going on there. So you want to get started with VI, you've got to understand, you bring up the Get Started window. Right? You open up a new project. You can open up a project from a template. That means somebody has got something that looks, it's a good first grab at what you're trying to do. Our templates would be templates that allow us to talk to the driver station. Right? So you open up this template. And then also on here, you've got a whole bunch of tutorials. You can open up projects from templates. You can open up existing projects you've done. You can go to tutorials. There's all kinds of FRC tutorials in this right off the LabVIEW page to help you control all those things. And then utilities and support are also down there as well. Okay. So there you go. You can go to support, look for FRC examples. If you have something you want to do, I've got 100 people who have done it before, and they've uploaded examples for you to have a look at. Okay. So if we decide to create a new robot, right? So what we're going to do is we're going to make a new FRC RoboRio robot project. So we'll click on that from a template, right? It's going to be a new template, RoboRio robot. It's going to be my first robot program. We'll do this during quick build. I think it's probably the easiest way to get our robots running on January 8th, 7th, 9th, January 9th, right? So you'll click on that template and up will pop this. What do you want to call it? Well, this guy called it 2013 Robot Project. This describes where it is. Then you have to give it the IP address in here, so it knows what modem it's talking to. 10. I'll say let's say 4334, so it'll be 10.43.34.2. right? Where it is, and then basically some information. I want to have an arcade robot, which means it's like a joystick robot, right? Or I can have an omni-drive, mechanical drive robot. I want to have a mechanical drive so my robots can go sideways and forward and backward without turning. You've seen those cool robots, so I would click on that one. And there's hardware only arcade. So basically, gets you a few sets of, you know, very primitive kind of decisions you can make. So you choose what kind of robot you want. So if everybody says, I want to have omni drives on my robot, and you say, I can program that, click on the mechanical drive robot, and it'll build it for you. Okay?
So it builds it for you, sorry, and is there any way to see it in another language, or is it
If you dig deep enough, if you go into those
icons?
VIs deep enough, you'll actually get the code.
Code, okay.
Because basically, it all is code inside there, compressed into an image, right? Or shape.
Yeah, it's like a flowchart template,
Yeah,
and-
kind of like a flow chart.
like pseudocode.
Exactly.
Okay.
Right, but it's just a little bit more left brain oriented, you know? Okay, anyway, so it'll create a hierarchy, something like that. And you can see this is your whole project right here. It's got all kinds of files. We won't worry about those right now. But the most important one is your team code in here. And you've got all of these different little VIs, virtual instruments, one called begin. When your program first starts running, when it first wakes up, it always runs begin first. And you might have initialization stuff in there, you know, whatever you need to, maybe a message pops up or something. Begin, always the first thing to run. Autonomous mode is whenever you want to run a program in that first 30 seconds of the competition, which is autonomous, and that's where the big points are. That'll make or break you sometimes, the robots that can do autonomous, because you get a lot of points in those. Right? But that means it's got to run all by itself. All you have to do is write your code into autonomous, into that part, that VI. And then when it's in autonomous mode, that will automatically execute. And maybe autonomous is as simple as moving your robot ahead 5 feet and bumping something over or blocking a path or something. Anything. It's better than sitting there, right? So put it in there. Teleoperate it. Any special code you want to put in your robot besides just driving around with your controller, you would put in the teleoperate region. Testing is for testing your robot, just for trying things out, so you put code in there. Periodic tasks are tasks that happen once in a while, you know, every 10, 20 seconds or something, you want something to happen periodically, you drop it in there. There's a whole thing, if you've got to do vision systems, there's VIs for vision systems. You don't have to worry about using them if you don't want to. It's just there if you want. So anyways, with this, create the new robot will create that, right? Which has all those different elements. Okay? And then once you're in LabVIEW, then you can use the Getting Started window to get things kind of rolling. So I thought what I'd do just for a second is let's have a look at, let's try creating a robot right now from scratch, right? Well, almost from scratch. I'm not going to do the firmwares or anything on here. I'll just start programming them. So do you have any questions about that? Okay, all right. So, and you say yes. The driver station again is that LabVIEW program that's already pre-written, right? And the my driver station is already connected, and it actually sees it. It's set up right now for 4334. If I go, anyways. Yeah, 4334, so it's talking to that modem, which is set up for IP address 4334. It's in the IP address. It's communicating. It's got joysticks connected, because I've included the VI that has the joysticks. So it's got joysticks connected, but there's no code. The batteries are running at 13%. This green line right here is actually it's a moving graph, so it'll actually change with time. You'll see it kind of moving up and down. And it looks like we're in good shape to run. And my laptop battery's good, and hardly using any processing power. Okay, so let's write a code and put it in there and hook it up to the dashboard. So to do that, let's go in here. I'm going to bring up NI LabVIEW 2014. We'll just launch LabVIEW. Now I didn't buy this LabVIEW. They have a free 40-day trial, right? And when I came in this morning, It said, "Oh, your trial's expired, are you gonna pay for it now?" And I said, "Yeah, no." So I went and I changed my clock back to October, or to September 1st. And, I said, "Oh, I'm sorry, it isn't 40 days," so I got it back up again. So you can get the free LabVIEW, and you can experiment with it until, until you get the one with your kit. And then you've got it all efficient. You get the serial numbers and you can log in. Very generous. Okay, so I'm gonna open up, well, I could make a new project. Click on this one here, make a brand new project. Or I can open up one of the ones I did. So let me open up this one here I put together. Maybe before we do that, there's all the tutorials. Setting up RoboRio, setting up the radio, setting up a camera, setting up a robot project. All the tutorials are right there, right? And the utilities here, imaging tools for the RoboRio, all that gamepad tools, all that right there. And then there's support, check for updates and all this kind of stuff. So all these utilities are right there waiting for you. Let's go to projects. Let's open up 2015 robot project, LV Proj, which is the overall project. Comes up with this old screen right here. And in the screen is your target RoboRio-4334.local, which means it's going to be connected to. We won't worry about support code right now, or we'll look at the team code. So there are all the different codes. When it's beginning disabled, when your robot is turned off at the end of the match, this disabled is automatically run, and it describes how your robot kind of locks itself up. Here we have finish, happens in the last 30 seconds. So when the last 30 seconds of your competition, you get these warnings. Well, that finish will help send the warnings to the driver. You will be running out of time. Anyways, all this, there's the tele-op period. This will run. This is the tele-op period. If you want to test it at your workbench, that's for testing. Vision processing is right in there. And robot main, this robot main right here, this is the big gear that ties all of those guys together. So this one right here is the one that calls all of those guys when necessary. So let's open up robot main. That's the good one. Robot main.vi.virtual instrument. And there's the panel. That's the control panel. Now, you could just stop right there if you want and run it from this point. Okay, I've got a error here. Vision system, it's not happy about my camera. Okay, I'm gonna fix that. So obviously it's complaining about one of my virtual instruments, and it wouldn't let me connect. One of my VIs is not running. So I don't know what it is. Let me have a look. So what you do is you go to Window. Now, let's look at the block diagram that defines this control panel. So open that up. And there is, you guys, this is the main program right here. When you begin, it starts here. It moves into this what's called a scheduling loop, which is involved in the main running of the program. It goes down here to a smart dashboard. This starts robot communication. This thing here gets robot communications going. I'm just going to touch it, all right? There's a vision system here. This is just bitching about that. I don't know what's wrong with it. I'm just going to take it out, right? And then there's a time, tasks showing up down there. So what I'm going to try to do here, oh, and a little, this is commenting right here. It describes sort of what's going on. Now, forgive me for a second, but I'm going to take out the vision. Delete. And then remove loose ends, so I'm going to get rid of that. And I don't need that, so I'll get rid of that. Okay, my vision system is gone now, right? Let's see if I can run it. Close. Vision system, software library. The vision system software is expired. Okay, so it's probably...
So is that what they call a compiler? Is that how they just check to make sure that your
program's
it's
working?
Just a licenser
Oh, okay.
probably checking to see what's on there.
Okay.
Okay, so I'm going to close this one here.
Like if you make a mistake in there,
Yeah.
does it show you when you compile it?
Mm-hmm.
Okay.
Yep, it will. Yeah, it will show you what's going on. Window, show block diagram. Okay, try to run it, and it says robot main VI wire has loose ends. I have a loose ends wire there someplace. That's probably that wire right there. So I'm going to remove loose ends. That means I had a connection from one VI trying to talk to another VI, but there was nothing there. So it was upset that there was a wire without a connection. Oh, look at that, my run box isn't broken anymore. This is a good sign. It's running. Okay? It is now doing what's called a deployment. So it says, you had a problem before, should we keep going on? I said, yeah, do that. So now it's deploying, it's running, it's checking every one of those little VIs, it's converting them to something called machine language, it's linking them, and sending them down to the image that's inside there. And you have to do this almost every time. You have to download, every time you make a change to your program, you have to download it to the RoboRio. Yeah, sure, save changes. I think that's a good idea. Oh, wait a second. That's not that from the computer. You do it the hard way. Okay, now according to this thing, it's running. So let's have a look at the dashboard now. Let's move this aside. And I'll move this aside. And this aside. Well, look at that. My dashboard, in fact, I'll just close these guys right now and minimize them. My dashboard says communications are good, robot code, joystick is good, so the thing is actually running code right now. So I should be able to operate my joystick, except I have to enable it. Good idea. You see, right now I haven't got it disabled. It's disabled right now. You have to enable the thing to turn it on. More often than once I was like, why isn't it working? Oh yeah, right. Right?
What did you just enable?
I turned on my driver station, my driver's panel.
Oh.
Right? And there you can see now it's enabled, and now
Motors are
my
working.
robots are working. Right? I've got it in tank mode, so those would be on either side of the robot. I'm going forward now. I'm going backwards. And look at the battery. You notice the little bumps in your battery? See? My battery is not very good, and it tends to get sagged down. In fact, if I see there's huge drops in here, I might actually reset my system. So I punch the power, I could actually kill the battery and reset my whole computer, and I would see it right there. Right? And I'm in teleoperated mode. If I go into other modes like practice mode, I can't touch that board, I have to do it this way. If I go into practice mode and enable it, then there's, is it going to make a noise? That's unfamiliar, right? So now the teleoperated mode is over. Oh no, it's in run mode. So now it's in autonomous mode, and I can't control it in autonomous mode. But now the bells have gone off. 30 seconds have elapsed. I'm in teleoperated mode. So my driver will step forward, grab the controls, and now it's on. All right? That makes sense? Yeah. This is the diagnostics dashboard. So as you see, as I move it, you can actually see the data. If you have a gyroscope in your robot, it would show up there. We don't have a gyroscope. This is for sending strings back and forth. This is a little text. Okay, there's my 3 minutes is up. The buzzer just went off. I'm the end of my match right now. There's a checklist. You can write down little notes to yourself or to your driver saying, don't forget to do this and this and this and this. Right? Little checklist. This is for reading all the variables. So if I press buttons and things like that, you see they all show up there. And I can use every button and thing on this controller in there if I want. So don't exit the driver station. Did I exit the driver station?
Can you activate a virtual robot? Is there a possibility to see that?
Just redo that. I think I killed my driver station. Darn it. There it is. It's alive. It's alive. I'll go into teleoperated mode so I don't have to play the game. It's working. So let's since we're in teleoperated mode right now, we're running the teleoperated VI. That's called from the robot main VI. So if I open up my teleoperated VI, there it is right there. Right? And if I look inside that, there's the block diagram for the teleoperated VI. And that's all there is to it. And any code I write, I can write any code I want or put together any blocks I want. I just drop it on these blank spaces here. And they will run whenever I'm in teleoperated mode. Just any code. If I want to have it say 8 plus 6 equals, 14 or whatever. Just drop it in there and it'll show up. Now there's a little bit of code that was put into the teleoperated VI that reads the joysticks. And there's the joysticks right there that are being read in. There's the drivers for the joysticks. This is the drivers. The joystick information goes to this thing. It's a special kind of a lookup table. And the output goes to this arcade drive, which goes to the motors. So this is a VI that talks to the motors, right? I can look at the numbers on there. I think I'm going too far, aren't I? But I can drop a probe on there and on there. So I put probe number 1 and 2 on my output of my joysticks. And now these numbers here represent my joystick values. You see them changing when I move my joystick around? There's -1, +1. There's -1, +1 on the Y value, right? Does that make sense? Sort of? It's not everything all drills into other things, right? And each of these guys are VIs that go into other VIs and other VIs and maybe even into some C code. Here's the arcade drive for the motors. And I'm opening up a can of worms, I'll bet, by doing this, but let's dig into it. Here it is. There's everything about the motors. Motor left, motor right. It's a pulse width modulation motor. It's a Talon. It's called device 0. Well, this is the PWMs I'm using. I'm using the PWM ones, right? M1s, and everything about the motors right in there. Okay. And if I want to drill into this to see what blocks are underneath it, this is what a motor looks like inside, if you're interested in looking at that code. But if you don't care, you don't even worry about it. You just don't drill into it, right? You can play with that if you want to learn a little bit more, but yeah, it's great. And you can single step through your program 1 step at a time, and the blocks will light up as they're executing, and you can see the data moving along the paths. That's sort of the idea behind LabVIEW.